This will be a quick demo of a control program I wrote to move a Dash robot around like a logo turtle on this alphabet mat being treated like a grid. I'm not going to go into a lot of the implementation or other details, so see the linked project for more information. The first thing I want to show is setting the settings here to be using the simulation mode instead of connecting to the actual robot. This was mostly made to make the GUI development a little more straightforward. Since there's no absolute positioning in this system, I have to manually set where the start location and the goal are before I start. Here I'm using this little toy controller to control the send the commands to the system. This was hacked to publish its button presses to Wi-Fi, which are being used to queue up a bunch of commands for the bot to run. Once I hit connect here, it will send this to the simulation, which will just quickly run through them in the GUI. Now I'm going to go back to the settings and put it back to connect to the actual robot hardware. And once that's done, I'm going to do a quick demo of this NFC reader system that I set up. It's basically a NFC reader connected to a Wi-Fi microcontroller that will publish the direction of these cards over MQTT, which I'm showing a client for in the terminal here. These can be used along with the controller as substitute inputs to just pressing the arrow keys on the computer to control the robot or queue up commands. After fumbling a minute here to remember how to actually run the command to connect to the actual robot, I get it connected. Once again, I have to set up the initial positions, and once that's all set up, I use the cards to drive the bot around for a bit. It shows a little bit of the obstacle avoidance here, where if there's an obstacle that is not able to be seen from the tile that the bot is currently on, you can send a command to try to drive onto that block, and the bot will reverse once it detects that a crash is imminent. For bigger obstacles, or ones that are closer that it can detect from before it moves, they'll be added to the map as block squares, and the robot won't be able to be commanded to move into those spaces. Now I disconnect from the robot so I can queue up some new commands, and here I send the commands to finish this maze. Once it's reconnected, it'll send these to the robot in order, and if there's any obstacles that would stop it, it aborts the rest of the sequence. And here it'll finish the maze and do its little dance.